Okay, so there's actually some important formulas here that we need to know as well. First being speed. Okay, so the formula for speed is distance travelled over time taken. There's how far I've travelled, total, over time taken. Remember, distance is only ever going to be positive. Okay, so velocity is very similar to speed, but we actually have direction. Now why is that? Well, velocity is the change in position over the change in time. And change in position is essentially equal to displacement. Why? Because a change in position is talking about how far we've moved from our original position. Now displacement, you can go up or down, so therefore we can have positive or negative values. So velocity, like I said, considers direction, or v equals s over t. Okay, so let's have a look at finding the average speed and velocity over the first 16 seconds, 97 seconds, and 161 seconds. So starting off with 16 seconds, and we'll find the speed to start off with. So speed is equal to distance travelled over time taken. Okay, so how far have I travelled for the first 16 seconds? Well, I've gone from 21 down to 14, so I've gone down 7 metres, but distance doesn't matter about which direction, so I've actually travelled a total of 7 metres over time taken 16 seconds, which is equal to 0.437 metres per second. Okay, time for velocity. Velocity equals displacement, so that is s over t, time. Right, well my displacement, I've actually gone down now, haven't I? So my displacement is actually negative. Unlike distance, which was a positive, because distance I've travelled a total of 7 metres, I don't care which direction. But my displacement now, I do care which direction. So because I'm going down, I've actually got a negative displacement. So it's negative 7 over the time taken. Well, that's still 16. Okay, well that's just going to be equal to negative 0.437 metres per second. Okay, so let's have a look at the average speed over the first 97 seconds. Alright, well speed, once again, is equal to distance over time taken. Okay, so speed is equal to total distance. Well, my distance here is 7 metres, plus how much further have I gone? I've got another 14 metres, plus an extra 35 metres, because I've gone up, over time taken. Well, it's 97 seconds, which is equal to 56 over 97, which we'll find to be 0.577 meters per second. Right, looking at velocity now. Velocity is equal to displacement over time. Okay, so my displacement is, I'm at 35 meters, final position, minus 21 being my initial position, over 97. Displacement, 35 minus 21 is 14 over 97, which we'll find out to be 0.144 meters per second. So as you can see, the speed and the velocity over the same amount of time are quite different, because velocity is just talking about how far we've travelled from our initial position. It doesn't care about all the other stuff in between. It just cares about my final position from my initial position. Okay, and let's have a look at our average speed over the first 161 seconds. So remember, speed is equal to distance over time. Okay, well, how far have we travelled? We've travelled a total distance of 7 plus 14 plus going up 35 plus coming back down 14 plus going back up 7 over time taken. Well, that was 161 seconds. Okay, well, let's have a look at that. That is actually equal to 77 meters. We've travelled a total of 77 meters over 161 seconds. Therefore, my average speed is going to be equal to 0.478 meters per second. Now let's have a look at the velocity over the first 161 seconds. So velocity is equal to displacement over time. So I started off at 21 meters, and then after 161 seconds I finished at 21 meters. So my displacement is actually Nothing, because I don't care about all the other stuff in between for displacement. I only care about my final position and my initial position. So therefore, displacement being 0, so therefore I get 0 over time 161. Well, that's going to be equal to 0 meters per second. So once again, you can see that the speed here and the velocity are actually quite different. So let's have a look at one more example of a question you're likely to get when working with motion graphs. Okay, so this worked example says, use the position time graph at right, which shows the position of a particle x travelling in a horizontal straight line at any time t to find A, where the journey started, B, in which direction the particle initially moved, C, when and where the particle changed direction, D, when and where the particle finished its journey, E, if the velocity of the particle between t equals 2 and t equals 4 is positive or negative, and F, if the particle is speeding up or slowing down. Okay, there's a lot of questions here, but you can get all of this information quite easily just from this graph shown at right. Okay, so let's break it down. Let's do one at a time. So first question says, where did the journey start? Well, the journey starts when t is equal to 0. That is, when everything starts. When time is 0, that's the very beginning. So, when time is equal to 0, if we come up to the graph, our journey starts actually where our displacement is 10. So, when t equals 0, x equaled 10. Therefore, the journey started 10 meters from the origin. The origin being at this point here at a distance of 0 meters. Okay, the next question says, in which direction the particle initially moved? So you can see here that the particle starts at 10, and then over time it's getting closer and closer towards 0. Therefore, the particle is moving towards the origin. The next question asks, when and where the particle changed direction? Okay, so we can see here that it starts off at 10, it's going down closer and closer, getting closer and closer towards the origin at a distance of 0. Alright, at this point here too, you can see that it decides to go back and start heading away from the origin. Alright, that is, it's getting further and further away from the origin. So at what point did it change direction? Well, it's at the point where it changes from moving towards the origin to the point where it starts moving away from the origin. That is at t equals 2. So after 2 seconds, the particle changes direction and starts moving away from the origin. Next question asks when and where the particle finished its journey. Okay, well that is at the very end of the line. So you can see here that the particle finishes after 4 seconds at a distance of 20 meters from the origin. So the particle finishes after 4 seconds at a displacement of 20 meters away from the origin. The next question asks if the velocity of the particle between t equals 2 and t equals 4 is positive or negative. Okay, so let's have a look at this. We're going to draw a straight line from t equals 2 to t equals 4. Now, because velocity is the gradient of a displacement time graph, the gradient of this line is actually positive. So therefore, the velocity of the particle between t equals 2 and t equals 4 is positive because the gradient is positive. Also because the particle is heading in the positive direction. The final question asks if the particle is speeding up or slowing down. Well, if we have a look here at t equals 2, you can see that the gradient of this graph is becoming steeper and steeper. That is, if I had a little dude walking along here, he would find it increasingly difficult as he got further and further along the graph. Now remember, the gradient of a displacement time graph is equal to velocity. So therefore the gradient is getting steeper, and because the gradient is getting steeper, the velocity is becoming greater. But the question is not actually asking about the velocity, the question is simply just asking if it's speeding up. Well, if velocity is increasing, that is, if it's becoming greater and greater in magnitude, then yes, the particle is speeding up.
Whoa, it's okay guys, it's just me, Mr. Moore, monkey about. Alright, I hope you enjoyed today's lesson on motion graphs. Remember to stay tuned for the very next one. It's all on rates of change of polynomials. Okay, of course, say hi to your maths teacher for me. Morsey out.
This episode has been brought to you by our new toast cooking friend, Bevel.